bathroom, but the exhaustion of chewing.
Do you remember?
Okay. Right. And why she wants carrots when it is so tiring? Alright. Okay, come, let's go to this question. Right, so start off, fill in everything you've got. Right, so it says, a sports scientist is looking for ways to throw a heavy object further. The diagram below looks at two throws here and models them according to blah blah blah. So they're both parabolas. So if they're both parabolas, they're both symmetrical about the turning point. The first throw starts at 0, it reaches its maximum height at h and lands at m. The next one goes, reaches the maximum height at 4, 2, and then lands at n. Okay, if the second throw is 2 meters further than the first throw, then what are the coordinates of point h? So, highlight the two different parameters in different colors. So there's h, okay, we're looking for, okay, h is on the red, okay, this point 4, 2, okay, lies on both, okay. You with me? Okay. So, first thing I'm going to do is, so I want to figure out the coordinates of h. Well, I've got to use symmetry, right? So, if this parabola is symmetrical, that's 0, the turning x coordinate of the turning point is 4, then the x coordinate of n is equal to 8, right? So the x coordinate of n is 8, a mark for that. That's just symmetry. You have to use symmetry with parabolas. But this was 2 meters further. So if I go back to what's the x coordinate of m? 6. Right, so the x coordinate of m is equal to 6. The question is, I want the coordinates of h which lives on that red parabola. I could get the x coordinate straight away by using symmetry, right? If that's 0 and 6, what's the x coordinate of h? 3. What's the problem though? I don't know what the y coordinate is. To find the y coordinate, if I've got an x coordinate, I'm first going to have to find the equation of that red parabola. To find the equation, you've got two formulas which you're not given. If you're given the x-intercepts and another point, that's the formula you're going to use. Y is equal to a, x minus x1, x minus x2. If you're given the turning point, you're going to use y is equal to a, x minus b squared plus q. So in this case, we're going to use this one over there. So on that red parabola, we're going to have y is equal to a, x minus x1, x minus x2. So what are my two x-intercepts on the red one?
0 and 6.
Okay, 0 and 6. So it's going to become what?
Y equals
a, x minus
0,
x minus 6. Right? Which is just the same thing as y is equal to ax times x minus 6, right? You've still got to go find a. Okay, to find a, I need another point on that red parabola. Do I have one? Yes. Which is the point? 4, 2, right? So I'm going to sub in 4, 2 and solve for a. What do we look at the graph? Should a be positive or negative? That's little a. Negative, because it's sad, right? Okay, so I'm going to get 2 is equal to 4a, replacing x with 4 times 4 minus 6. Okay, so I get 2 is equal to 4a times negative 2. So 2 is equal to negative 8a. Divide by negative 8. Negative 2 over 8 is equal to a. So in other words, negative a quarter is equal to a. Are you happy with that? Okay. What was I trying to do then? I'm trying to find the equation of that red parabola. Okay. So now what have I got? I go back to here. And I replace a with negative a quarter. So the equation becomes y is equal to negative a quarter x times x minus 6. Okay, we can leave it like that. You can times it out if you want. But that's the equation of the red parabola. Okay. So now, because of symmetry, we know that the x coordinate of the turning point is equal to 3, right? So I've got an x coordinate of a point, how do I find the y coordinate both ways? Sum into that graph over there, right?
Yes.
So my x coordinate of my turning point is 3. So the y coordinate of my turning point must be equal to negative a quarter times 3 times 3 minus 6. Stick that into your calculator. What do you get? Negative 9 over 4. No, positive 9 over 4. Right? So your y coordinate of your turning point is equal to 9 over 4. Always make sure you've answered the question. What was the question? What are the coordinates of h, right? So the coordinates of h are going to be 3 and 9 over 4. Does it look kind of right? Well, 3, 9 over 4. 9 over 4 is 2 1/4, and it's a little bit higher. That was dead right. Okay, so that's 3, 9 over 4. We're good. Yeah. All right. One of the questions I wasn't charged with this question once upon a time. Okay, right now. Okay, the next one is quite a nice question. Everyone happy up to there? I'll give you a minute to get it done. Guys, there's no harm in doing this paper again in a couple of weeks' time. Trust me, it'll be like doing it for the first time. Okay. Start the next one if you haven't yet. What are you up to? Plotting something bad.
I'm not even doing anything.
Yeah, but you're thinking about
I was
that.
just saying the beer.
tissues.
Why delta? What's delta?
Yeah.
Sorting. What is delta? Like what does it tell us?
Just get on with your work.
Like real.
Yes, stop plotting. Working.
Hello, sir.
Yes, I see you plotting.
No, we're talking about work.
Well,
Why are you laughing, sir?
It's funny.
Sir! Sir!
So don't talk to me like that. So accusing her false.
I'm so sorry.
Don't do that.
To apologize.
I don't know. Only do we accept your apology? Oh, she's deliberating.
Let's talk about math.
Sir, what do you think your new colleague, well, your colleague,
So
has changed appearance?
it's less than zero.
Colleague changed.
Colleague changed the appearance.
Your colleague, co-worker.
Oh, taxi.
Yeah.
Yeah, quite clever. Eh?
Yeah, it looks so
It's a bit scary how someone did it. Okay.
That's so scary.
I haven't seen Gavin today.
She looks like a mom. She looks exactly like a mom. Literally.
What is Gavin just done?
Grandma Mercedes. Yeah.
Right, can we go with this question quickly? Right, so let's have a look at this question. This is nice. I like these kind of questions, guys. So, first thing over here. Okay. So you've got a quadratic function, which tells you what kind of graph is it, first of all. So it's a parabola. So we know that. Right? And it has the following properties. So what the hell does this mean? Okay, well the best way to explain it is this. Do you remember this? If I said to you f of x was equal to, you had a graph f of x, right? Let's say it was equal to x squared plus 2x minus 3. Okay? And I said to you, go shift that graph 2 units to the right. What would you do? You replace every x with what? With x minus 2, right? So it would become x minus 2 squared plus 2 times x minus 2 minus 3. Okay, but if I just told you it's f of x, and forget about the actual equation, even if I didn't know the equation, any equation in the world, if I've got f of x and I want to move it 2 to the right, I change every x into x minus 2, so it becomes f of x minus 2. That shifts the graph 2 to the right, no matter what kind of graph in the world it is. Because it means replace every x with x minus 2. If I took the same thing over here, some graph f, and I wanted to shift it 3 to the left, what would I do? I'd replace every x with x plus 3, so to become, so f of x plus 3 is f of x shifted 3 to the left, no matter what kind of graph in the world you work with. You don't need to know the equation. Kabish. What does this mean? If you've got f of x, what's happened? Every x has changed into a negative x. If every x changes signs,
Reflected by the y-axis.
this is a reflection about the y-axis. And if you've got f of x and it's negative f of x, what's that? Every y has changed sign, because f of x is what? That's a reflection about that. So they like these kind of thing will crop up somewhere around there. Okay, understanding shifts. So in this question over here, what the hell is this telling you? Well, if we had a graph of f of 6, okay, what does that mean? It means when the x coordinate is 6, what's the y coordinate that goes with it, right? Okay, so that when the x coordinate of f is equal to 6, f of 6 is the y coordinate that goes with it, right? If I said to you, go shift this unit, this point, okay, p units to the right, what would f of 6 become? F of 6 minus p, right? Then I've shifted the p units to the right. You with me?
Yes.
If I said go shift this p units to the left, what would it become? F of 6 plus p. So what are they saying to you? If you start with the y coordinate when x is equal to 6, okay, and you shifted p units to the right and p units to the left, then the y coordinates will be equal. Okay, this is quite a tough concept. You with me? So what does that mean in terms of a graph? It's saying to you that if you have some graph, I'm not going to start drawing it yet, and the turning point is at 6. So that, right? Where's the graph going to be? The graph is symmetrical about, a parabola is symmetrical about the x coordinates of the turning point. You with me? So if I take 6 and I go move it p units to the right, so now I've got 6 plus p, right? Then this point will be 6 plus p, f of 6 plus p, right? If I go p units to the right. You with me?
Yes.
If I go p units to the left, let's say it's over there.
Yes.
Okay, then they're saying if I go p units to the left, okay, then this will be f of 6 minus p, right? And what are they saying? They're saying that they are equal to each other. Okay, they're saying the y coordinates, when I go p to the left from 6 and p to the right from 6, then the y coordinates will be the same. Which means what? That the graph is symmetrical. When they're symmetrical, when it goes p across and p across, okay, they're going to be symmetrical about which point? About 6, right? And if they're symmetrical about 6 on a parabola, what does that mean? The x coordinates of the parabola must be 6. If I said to you f of 3 minus x is equal to f of 3 plus x, what would be the turning points? The x coordinate of the turning point would be 3, because if you go x to the right or x to the left, the y coordinates stay the same. It's a tough concept, that. Okay, I hope it makes some kind of sense. Okay, so the first thing that you know about this parabola, because you've got to draw a sketch of it. So the first thing I would draw in is, remember the x coordinate of your turning point, okay, is your axis of symmetry, right? So far I know that this graph turns, that the axis of symmetry is at x is equal, that's not an asymptote, that's the axis of symmetry, right? So it turns on that line. It's symmetrical about that line because of this bit of information here. Kavish? Right. The next bit of information. Well, this negative b over 2a. Hey, what does that thing? That gives you, if you've got a parabola of the form y is equal to ax squared plus bx plus c, the formula for the x coordinate of the turning point was negative b over 2a, right? Okay. So what does f of negative b over 2a give us? It gives us the y coordinates of the turning point. Does that make sense?
Yes.
So what are they telling us? The y coordinate of the turning point is 2. So do I know the x coordinate of the turning point? So what's the turning point then? The turning point is at 6, 2. Okay, so the first thing we know is that the turning point is at 6, 2. That's your turning point. That comes from those two bits of information. Kavish? Okay. The last bit of information says that b squared is less than 4ac. Well, what's that telling you about? b squared minus 4ac, right? What was b squared minus 4ac equal to? Delta, which determines the nature of roots. Where does delta come from? It comes from the quadratic formula, right? That says your x-intercepts are equal to negative b plus minus delta over 2a, the quadratic formula, right? So, delta is going to determine the nature of the roots. What does that nature of roots mean? What type of answers, in other words, what type of x-intercepts you're going to get? Okay. So if b squared minus 4ac is less than 0, I'll move that across. In other words, they are telling us that delta is a negative number. Where does delta live? Under the house. So if that's under a house, the square root of a negative number is? It's imaginary, it's non-real, right? So my roots are non-real. What does that mean in terms of graphs? If your roots are non-real, there are no x-intercepts. So by telling you that b squared is less than 4ac, they are telling us delta is negative. If delta is negative, that's where delta lives. Okay, we're going to have no real solutions. The roots are your x-intercepts. So if I go back to the graph now, is this graph going to be happy or sad if there are no x-intercepts? Well, it has to be happy if it turns over there, right? And there's your sketch. Question. I wish you well as you go forth into the world.
I wish we had.
We have IT. It's actually useless and this can be a and we still have to get to question 12. This is only question 8. You get the full This needs a lot to be perfect.
Because I'm using this formula. Y is equal to A. There should be an x here. X minus 0 is? X. You with me? X minus 0 is that's x. So I get y is equal to ax times x minus 6. Then I sub in the point 4 negative 6. What is the point? 4, 2. Okay, so I've got y is equal to a x minus 6. You with me?
Yeah.
Okay. Then I sub in this point 4, 2.
Yeah, so then I say.
Which means I have to replace every x with 4 and every y with 2, right? So I get 2 is equal to a, replace that x with 4, replace that x with 4.
So
And
that's
you
just the formula. X
2,
is next to A.
yeah, 2 is equal to 4a times negative 2, and then we go from there.
Thanks, sir.
Okay.
Thank you.
Okay.
What are words? Those other issues that we voted for, like the then there's on the top of each subject.